This lecture will answer two questions. In the first question, we find out the radius of this circle, and in the second question, we find out the area of this green shape using two different methods. So we start with the first question. In the drawing, we have a circle that blocks quadrilateral ABCD. Or quadrilateral ABCD is described by this circle. AB equals to AD equals to 4, side BC equals to 6 units in its length, side DC equals to 8 units in its length. Again, our task is to find out the radius of this circle. So, first of all, we find this angle BAD is theta. So here we can use rule 70, we can implement rule 70 in our drawing. I click on rule 70. According to rule 70, in a cyclic quadrilateral, the sum of the opposite angles is equal to 180 degrees. In the drawing, we have quadrilateral ABCD that is described by this circle, and according to this rule 70, because of the fact that quadrilateral ABCD is cyclic quadrilateral, the sum of its two opposite angles is equal to 180 degrees. That is to say, alpha plus beta equals to 180 degrees. Likewise, gamma plus delta also equals to 180 degrees. So we can implement rule 70 in our drawing. Because in our drawing, quadrilateral ABCD is described by this circle, and therefore the sum of those two opposite angles must be equal to 180 degrees according to rule 70. So angle theta plus this missing angle in total must be equal to 180 degrees. Therefore this missing angle must be equal to 180 degrees when theta is size. Well, because 180 degrees minus theta plus theta equals to 180 degrees. That is the sum of those two opposite angles according to rule 70. So, in the next step, we will join points B and D together by straight line. By joining points B and D, we divided this quadrilateral ABCD into two triangles. We have the upper ring triangle ABD, this is the lower triangle BCD. So in the next step, we will implement the law of cosines on both triangles. So first of all, we will implement the law of cosines in this main triangle ADB. So quick on the law of cosines. The law of cosines is true in any triangle. So this is triangle ABC that could be any triangle. Side AB equals to A units in its length, side AC equals to B units in its length, side BC equals to 3 units in its length. This angle BAC is equals to theta degrees in its size. So in this triangle ABC that could be any triangle, the following equation is true. C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Again, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. So we can actually implement the law of cosines in this given triangle ABD. According to the law of cosines, this given triangle ABD, BD squared equals to AB squared plus AD square minus 2 times AB times AD times cosine theta. Repeat again, in this again time ABD according to the law of cosines, the following equation is true. BD square equals to AB square plus AD square plus 2 times AB times AD times cosine theta. This equation is the implementation of the law of cosines in the great triangle time ABD. BD is the missing side, so leave it as it is. So it is BD square equals to AB square. AB is 4, therefore AB square is 4 squared, this is 16. Plus AD square. AD is also 4, therefore AD square is 16. Minus 2 times AB is 4. Times BD is also 4, times AD is also 4, times cosine theta. So in total, according to equation 1, we found out that BD square equals to 16 plus 16 plus 2 times 4 times 4 times cosine theta. So BD square equals to 16 plus 16 is 32 minus 2 times 4 times 4, 4 times 4 is 16 and 16 times minus 2 is minus 32. So in total this expression equals to minus 32 times cosine theta. So I should find out that according to equation 1, BD square equals to 32 minus 32 times cosine theta. So in the next step, we will implement the law of cosines in this triangle DBC. According to the law of cosines, this triangle DBC, DB square equals to BC square plus DC square minus 2 times BC times DC times cosine 180 degrees minus theta. And again, according to the law of cosines, in this right triangle DBC, the following equation is true. DB square equals to BC square plus DC square minus 2 times BC times DC times cosine 180 degrees minus theta. Actually, we have the trigonometric identity that says that cosine 180 degrees minus theta equals to minus cosine theta. Therefore, we substitute cosine 180 degrees minus theta in this equation, equation 2, by minus cosine theta. And you get that dB square, according to equation 2, dB square equals to BC square. BC is 6, therefore BC square is 6 squared, that is 36, plus DC square. DC is 8, therefore DC square is 8 squared, that is 64, minus 2 times BC is 6, times DC is 8, times cosine theta. So total according to equation 2, if we found out that dB square equals to 36 plus 64 is 100. Here we have minus 2 times 6 is minus 12, and minus 12 times 8 is minus 96. So total this expression equals to minus 96 cosine theta. So according to equation 2, if we found out that dB square equals to 100 minus 96 times cosine theta. So according to equation 1, dB square equals to 32 minus 32 times cosine theta, and according to equation 2, dB square equals to 100 minus 96 times cosine theta. So we have two different equations for dB square, equation 1 and equation 2, therefore we get equation 3 that states that dB square according to equation 1 must be equal to dB square according to equation 2. Very simple equation. So dB square according to equation 1 equals to 32 minus 32 times cosine theta. It must be equal to dB square according to equation 2. dB square according to equation 2 equals to 100 minus 96 times cosine theta. So total according to equation 3, if we found out that 32 minus 32 times cosine theta equals to 100 minus 96 times cosine theta. So here we subtract 32 from this equation 3. We get this according to equation 3. Here 32 will get cancelled. So in this side of the equation we left only with minus 32 times cosine theta. This is equal to 100 minus 32 is 68 minus 96 times cosine theta. So then we found out that minus 32 times cosine theta equals to 68 minus 96 cosine theta. Now here we will add the 96 cosine theta to this equation. Okay, here we have dB square equals to 100 minus 96 times cosine theta, but we have the trigonometric identity that says that cosine 180 degrees minus theta equals to minus cosine theta. Therefore, we substitute cosine 180 degrees minus theta in this equation by minus cosine theta. Therefore, here we have minus times minus is plus, which is plus 96 cosine theta. So here we have also plus 96 cosine theta. So total according to equation 3, we found out that minus 32 times cosine theta equals to 68 plus 96 cosine theta. So here we subtract 96 cosine theta from this equation. So here 96 cosine theta will get cancelled. So in this side of the equation we'll have to leave with 68, while on the other side of the equation we have minus 36 cosine theta minus 96 cosine theta equals to minus 128 cosine theta. So in total we found out that according to equation 3, minus 188 cosine theta equals to 68. So here we divide this equation by minus 128. And you get that according to equation 3, cosine theta equals to 68 over minus 128. So it is minus 68 over 128. So here we divide both the numerator and the denominator of this number by 2. 68 minus 68 over 2 is minus 34 over 188 and 128 over 2 is 64. So here we divide both the numerator and the denominator of this number by 2. Minus 33 over 2 is minus 17. And 64 over 2 is 32. So those two sides of the equation are equal to each other. So in total we actually found out that according to equation 3, cosine theta equals to minus 17 over 32. So we have the trigonometric identity that says that sinus square theta plus cosine square theta equals to 1. So here we subtract from this trigonometric identity cosine square theta. And get that according to this trigonometric identity, sinus square theta equals to 1 minus cosine square theta. So here we take a root out of this equation, and finally we get that sinus theta equals to the square root of 1 minus cosine square theta. We already found out that cosine theta equals to minus 17 over 32. So if we square this equation, we get that cosine square theta equals to minus 17 over 32 squared. Minus 17 over 32 squared equals to 0.2822. So if you found out that cosine square theta equals to 0.2822. Therefore, we can substitute cosine square theta in this equation by 0.2822. We do it now, we get that sinus theta equals to the square root of 1 minus cosine square theta, that is actually 0.2822. So in total, if we found out that sinus theta equals to the square root of 1 minus 0.2822 is equal to 0.717. 0.7177, and the square root of 0.7177 is equal to 0.847. And again, in total, if you found out that sinus theta equals to 0.847, what is the value? What is the length of this side BD? According to equation 2, according to the first equation, we found out that dB squared equals to 32 minus 32 times cosine theta. So I copy this equation here. According to equation 1, we found out that dB squared equals to 32 minus 32 times cosine theta. So dB squared equals to 32 minus 32 times cosine theta. Cosine theta equals to minus 17 over 32. So total, if you found out that dB squared equals to 32 minus 32 times minus 37 over 32. Minus times minus is plus, so this expression is a positive expression. So it is equals to 32 plus 32 over 32 times 17. We have 32 in the numerator, 42 in the denominator, so 32 get cancelled. The left only if dB squared equals to 32 plus 17 is 49. So if we found out that dB squared equals to 49, here we take out all of this equation and finally get that dB equals to the square root of 49, that is 7. dB equals to 7. And we only found out that sinus theta equals to 0.847. In the next step, we'll implement the law of sines in this rectangle, triangle ABD. So a bit quicker of the law of sines. The law of sines is true in any triangle, so this is triangle ABC that could be any triangle. So in the drawing we have a circle that blocks triangle ABC, or triangle ABC is described by this circle. We know that AB equals to C units in its length, AC equals to V units in its length, BC equals to A units in its length. This triangle BAC this is equal to capital A degrees inside. This is angle ACB, this is equal to capital C degrees inside. This is angle ABC, this is equal to capital B degrees inside. So in this drawing, according to the law of sines, the following equation is 2. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks triangle ABC. So we can implement the law of sines in our drawing. The red triangle ABD is described by this circle. Why? Because of the fact that all the three vertices of this red triangle ABD lie on the circle. Therefore, we can implement here the law of sines. According to the law of sines, this red triangle ADB, the following equation is 2. dB over sinus theta equals to 2R. Again, dB over sinus theta equals to 2R. And R is the radius of this circle that blocks the red triangle ABD. This is actually the radius that we are looking for this question. dB 7 over sinus theta. Sinus theta equals to 0.847 equals to 2R. So total we found out that 7 over 0.847 equals to 2R. 7 over 0.847 is equal to 8.2644 equals to 2R. Here we divide this equation by 2, so we get that R, that is the radius of the circle that we are looking for, is equal to 8.644 over 2. 8.2644 over 2 is equal to 4.132 units. So if we found out that the radius of this circle, that is the radius that we are looking for, the radius R equals to 4.132 units in centimeter. Because again, the radius of this circle is equal to 4.132 units in centimeter. So we finished to answer the first question. The next step I present to the second question and answer the second question of this lecture. In the second question, our task is to find out the area of this green shape. What is the green shape? The green shape is actually triangle APC. So our task is to find out the area of this green triangle APC. So in the drawing, we have the big triangle ABC. This is the right angle. Angle ACB equals to 2 theta. AP equals to 5. PB equals to 4. Again, our task is to find out the area of this green shape. That is actually the area of triangle APC. So first of all, we implement the law that says that the sum of the angles in any triangle is equal to 180 degrees. And again, we implement the law that says that the sum of the angles in any triangle is equal to 180 degrees. So the big triangle ABC, the big right triangle ABC, this angle equals to 90 degrees. This angle equals to 2 theta, and therefore this missing angle must be equal to 90 degrees minus 2 theta. Why? Because 90 degrees minus 2 theta plus 2 theta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, in this lower right triangle PBC, this angle equals to theta. This angle equals to 90 degrees, and therefore this angle must be equal to 90 degrees minus theta. According to the symbol that says that the sum of the angles in any triangle is equal to 180 degrees. So, in the next step, we will do a construction, that is to say, from point P, this point P, we will go perpendicular on AC. Again, from point P, we will go perpendicular on AC. So okay, this angle equals to 90 degrees inside, and this angle also equals to 90 degrees inside according to our construction. We will define the touching point of the perpendicular from point P and AC. This point is point Q. So here we have, this is the right triangle PQC. In this right triangle PQC, this angle equals to theta. This angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus theta. According to the symbol that says that the sum of the angles in a triangle is equal to 180 degrees. What is the size of this missing angle APQ? Angle APQ here we use the rule that says that the sum of the angles in a triangle is equal to 180 degrees. So we have here 90 degrees. This small green triangle APQ. This angle equals to 90 degrees minus 2 theta plus this angle that is 90 degrees plus this missing angle. We find this missing angle as y. In total, the sum of those three angles must be equal to 180 degrees. So here we have 90 degrees plus 90 degrees is 180 degrees. So we subtract 180 degrees from this equation. Here 180 degrees minus 180 degrees is 0. So in this side of the equation we have 0, nothing. But on the other side of the equation, 180 degrees minus 180 degrees is 0. So we left only with 2 theta. We left only with minus 2 theta. Minus 2 theta equals to 0. Minus 2 theta equals to 0. Here we add 2 theta to this equation. Here we have y minus 2 theta equals to 0. In this equation we have y minus 2 theta equals to 0. Y minus 2 theta equals to 0. Here we add 2 theta to this equation, and we get that y equals to 2 theta. And we found out that the missing angle APQ is equal to y is equal to 2 theta. In the next step, we'll prove that those two adjacent triangles can point to each other according to side angle rule. Because again, we'll prove that the green upper right triangle PQC can point to this white lower triangle PBC according to angle side angle rule. So we have to prove that this is the green triangle, the green right triangle PQC. That it converts to this white lower triangle PBC. So why those two white triangles convert to each other? First of all, those two angles are both equal to, sorry, we don't need it. Those two angles are both equal to theta, therefore they are equal to each other. So here this is angle QCP, the green triangle PQC. And it is equal to this angle, it is equal to angle PCB in the white triangle. So again, if you found out that angle QCP in the green triangle equals to angle PCB in the white triangle. They are both equal to theta and therefore they are equal to each other. In addition, PC is the common side that belongs to both triangles. So we can write down that PC equals to itself is the common side that belongs to both triangles. PC equals to itself is the common side that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle QPC in the green triangle. And it is equal to this angle, the angle BPC in the white triangle. And again, if you found out that angle QPC in the green triangle equals to angle BPC in the white triangle. So both equal to 90 degrees minus theta, therefore they are equal to each other. So in total, if you found out that the green right triangle PQC congruent, this is the sign of congruent, to the white right triangle PBC, according to angle side angle rule. That is to say, if you found out that those two angles, the side that is included between those two angles, and actually side PC, are correspondingly equal to those two angles, and the side that is included between those two angles is also PC, this right angle, PBC. Therefore, those two right angles can go into each other according to angle side angle rule. We have those two angles, the side that is included between those two angles is the green triangle, are correspondingly equal to those two angles, and the side that is included between those two angles is the white triangle. And therefore, those two right triangles can go into each other according to angle side angle rule. And from the fact that those two right triangles can go into each other, we will derive that their corresponding sides must be equal to each other and their lengths. That is to say, PB equals to PQ. Why PB is the corresponding side to PQ? Because of the fact that PB is located in front of angle theta, likewise PQ is also located in front of this angle theta. So those two sides are corresponding sides. But PB is 4, so we can write here that PB is 4. And for this equation, 4 equals to PB equals to PQ, we'll derive that PQ must be also equal to 4 units in its length. This is the missing side PQ. That equals to 4 units in itself. It is very easy to see that the big right triangle ABC is similar to this small right triangle AQP. Why the green triangle AQP is similar to the big right triangle ABC, to the big right triangle ABC? First of all, those two angles are both equal to theta and therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, this angle is a common angle that belongs to both triangles, so I can write down that this angle equals to itself is a common angle that belongs to both triangles. So in total, I found out that all the three angles of the big right triangle ABC are corresponding equal to all the three angles of this small right triangle APQ. Therefore, those two right triangles can go into each other according to angle. Those two triangles, those two right triangles are similar to each other according to angle similarity rule. So okay, now we have found out that the big right triangle ABC is similar, this is the sign of similar, to this small green right triangle APQ. According to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We derive that side AP of the green small triangle or side AC of the big right triangle ABC is equal to side PQ of the small green triangle or side BC of the big right triangle ABC. But again, from the fact that the big right triangle ABC is similar to this small green triangle APQ, we derive that the following relationship exists between their sides. We derive that side AP of the green triangle or side AC of the big triangle and side AP of the small green triangle or side AC of the big triangle ABC equals to side PQ of the green small triangle or side BC of the big right triangle ABC. We define the length of AC as A and the length of BC as B. So we have AP is 5, over AC is A, equals to PQ is 4 over BC equals to B units in itself according to our definition. So in total we found out that 5 over A equals to 4 over B. Here we will cross multiply this equation and we get that 5B equals to 4A. So 5b equals to 4a. That is to say, if a equals to 5x, what is the value of b? You just substitute a by 5x. You get that 5b equals to 4 times a. A is 5x. So in total we actually found out that 5b equals to 4 times 5 times x. Here we divide this equation by 5. So here 5 will get cancelled, and the left only with b equals to, here 5 also will get cancelled, and the left only with 4x. In total we actually found out that if a equals to 5x, then b must be equal to 4x. Again, if a equals to 5x, then b equals to 4x. So if a equals to 5x, then b must be equal to 4x. In the next step, we will implement a Pythagoras theorem on this big triangle ABC. And again, we will implement the Pythagoras theorem on this big right triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here by PT is the expression for Pythagoras theorem. So according to the Pythagoras theorem, in this big right triangle ABC, AC squared is the square of the hypotenuse equals to AB squared plus BC squared. And again, according to the Pythagoras theorem, the big right triangle ABC, AC squared is the square of the hypotenuse equals to AB squared plus BC squared. AC equals to A and A equals to 5x. Therefore, AC squared equals to 5x squared, that is actually 25x squared. AC squared equals to 25x squared. And it equals to AB squared. AB in total, it is 5 plus 4, that is 9. Therefore, AB squared is 9 squared, that is 81. Plus BC squared. BC equals to B and B equals to 4x. So BC equals to 4x, and therefore BC squared is 4x squared. 4x squared is 16x squared. So we found out in total that 25 equals to 81 plus 16x squared. Here we subtract 16x squared from this equation. So here 16x squared will get cancelled, and we left only with 81. And on the other side of the equation we have 25x squared minus 16x squared is 9x squared. So in total we found out that 9x squared equals to 81. Here we divide this equation by 9 and find out that x squared equals to 81 over 9 is 9. So x squared equals to 9. Here we take a root out of this equation and find out that x equals to the square root of 9, that is 3. So x equals to 3 since 9. BC equals to B and B equals to 4x. 4x is 3, so 4x is 4 times 3, that is 12. So total BC equals to 12. Can you see this now? Likewise, AC equals to 5x, x equals to 3, so 5x is 5 times 3, that is 15. So total AC equals to 15 units in its length. And BC equals to 12. Our task is to find out the area of this given shape. So what is the area of this given shape? What is the green shape? The green shape is actually the triangle APC. So the task is to find out the area of this triangle APC. That is the green shape. Actually, we know that the area of any triangle equals to the base of the triangle times the height to the base over 2. And therefore, the area of this main triangle ABC must be equal to the base. We choose the base as AP times the height to the base. The height to the base must be greater than the base with the base. The base is AP, therefore the extended base is AB. So the height to the base must be 90 degrees with AB. BC definitely gets 90 degrees with AB, because this is the right angle. So the height to the base is BC. Over 2. AP equals to 5 times BC. BC equals to 12 over 2. So now we found out that they have the green shape equals to 5 times 12 is 60, and 60 over 2 is 30. So they have the green shape is equal to 30 square units in size. So, we finished with the first method. In the next step, I present to you how to find out the area of this green shape according to the second method. In this right triangle PBC, it is very easy to see that tangent theta equals to PB over BC. We define the length of BC as B. So tangent theta equals to PB over BC. PB is 4 according to what is given as a question. So I substitute PB by 4 in this equation 1 over BC. BC is B according to our definition. So total we actually found out that tangent theta equals to 4 over B. This is according to equation 1. In the next step, we'll focus on this big triangle ABC. This big triangle ABC. It's very easy to see that tangent 2 theta equals to AB over BC. AB in total equals to 5 plus 4, that is 9. Over BC, BC equals to B according to our definition. So in total, if you found out that according to equation 2, times 2 theta equals to 9 over B. This is according to equation 2. According to equation 1, we already found out that tangent theta equals to 4 over B. We have that trigonometric identity that states that tangent 2 theta equals to 2 times theta over 1 minus times square theta. We substitute times 2 theta in this trigonometric identity by 9 over B and substitute times theta by 4 over B. This is trigonometric identity. We do it now, we get that times 2 theta equals to 9 over B and it equals to 2 times tangent theta, so it is 2 times tangent theta. Tangent theta equals to 4 over B over 1 minus tangent square theta. Tangent theta equals to 4 over B, therefore tangent square theta must be equal to 4 over B squared. 4 over B squared equals to 4 squared, it is 16 over B squared. So tangent square theta equals to 16 over B squared. So here we must multiply this equation, equation 2. If I get it according to equation 2, 9 over B times 1/16 over B squared equals to, here we have 2 times 4 is 8, so this expression equals to 8 over B. So here we multiply this equation 2 by 1/16 over B squared. Therefore, on this side of the equation we have 9 over B times 1/16 over B squared. Well, on the other side of the equation we left with 8 over B. Okay, we left only with 8 over B. 2 times 4 is 8, so this expression equals to 8 over B. So total according to equation 2, we found out that 9 over B times 1/16 over B squared equals to 8 over B. We have B on both sides of the equation, so B will get cancelled. After we cancelled B, in this side of the equation 2 we left with 9 times 1/16 over B squared, and it equals to 8. Here we'll open the brackets on this side of the equation and get that 9 times 1 is 9, and 9 times 1 16 equals to minus 144 over b squared, and it is equal to 8. Here we subtract 8 from this equation. We get that according to equation 2, 9 over 8 is 1, minus 144 over b squared equals to 0. So here we add 144 over b squared to this equation, and when we get that according to equation 2, 1 equals to 144 over b squared. Here we multiply this equation by b squared, and we get that b squared equals to 144. Here we take out of this equation, and when we get that b equals to the square root of 144, that is 12. So total we found out that b equals to 12 units instead. This is side BC equals to b equals to 12 units in itself. Our task is to find out the area of this green shape. So what is the area of this green shape? The area of this green shape equals to the area of this triangle APC. In triangle APC. And again, the area of the green shape is equal to the area of the green triangle APC. And actually we know that the area of any triangle equals to the base of the triangle times the height to the base over 2. So we choose the base of this green triangle ABC is AP, and the height to the base must create 90 degrees with the base or with the extended base. The extended base AP is AB, and CB definitely creates 90 degrees with the extended base AB. Therefore CB is the height. CB equals to B, and B equals to 12. Over 2. AP equals to 5. So here we have 5 times 12 over 2 is the area of the green shape. 5 times 12 is 60, and 60 over 2 is 30. So in total, if you found out that the area of the green shape is equal to 30 square meters in size. And again, we should find out that the area of this green shape is equal to 30 square meters in size. So, we finish with the second method. So in the next step, after the lecture, so we repeat on the solution of the first question, then we repeat on the solution of the second question with both methods. So we start to repeat on the first question, the solution of the first question. our task in the first question was to find out the radius of this circle. The circle blocks a quadrilateral ABCD, or quadrilateral ABCD is described by this circle. AB equals to AD equals to 4, BC equals to 6, CD equals to 8, and then again our task is to find out the radius of this circle. So first of all, we define this angle EAD as theta. So here we have quadrilateral ABCD that is described by this circle, and therefore we can implement here rule 70. Okay, click on rule 70. According to rule 70, in a cyclic quadrilateral, the sum of the opposite angles is equal to 180 degrees. So the moment we have quadrilateral ABCD that is described by this circle, therefore the sum of those two opposite angles must be equal to 180 degrees. That is to say, alpha plus beta equals to 180 degrees. Likewise, the sum of those two opposite angles must be also equal to 180 degrees, according to this rule, rule 17. That is to say, gamma plus delta equals to 180 degrees. So we can implement rule 70 in our domain. I'll put in our domain. This is quadrilateral ABCD that is described by this circle. Therefore, according to rule 70, the sum of those two opposite angles must be equal to 180 degrees. But this angle equals to theta according to our definition. Therefore, this missing angle must be equal to 180 degrees minus theta. Well, because 180 degrees minus theta plus theta is equal to 180 degrees. That is the sum of the angles of those two opposite angles according to rule 70. Therefore, this missing angle must be equal to 180 degrees minus theta according to rule 70. In the next step, we join points B and D together by straight line. By joining points B and D, we divided this quadrilateral ABCD into those two triangles. So in the next step, implemented the law of cosines on both triangles. So please click on the law of cosines. The law of cosines is true in any triangle, so this is triangle ABC that could be any triangle. AB equals to A unit instant, AC equals to B unit instant, BC equals to C unit instant. This is angle BAC is equals to theta degrees in size. So this triangle ABC that could be any triangle, according to the law of cosines, the following equation is 2. C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Again, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. So we can implement the law of sines. This triangle ABD. So this triangle ABD, according to the law of cosines, BD squared equals to AB squared plus AD squared minus 2 times AB times AD times cosine theta. So again, this triangle ABD, according to the law of cosines, the following equation is 2. BD square equals to AB square plus AD square minus 2 times AB times AD times cosine theta. So this triangle ABD turn into the law of cosines. BD square equals to AB square plus AD square minus 2 times AB times AD times cosine theta. And again, this again triangle ABD according to the law of cosines. BD square With again the green triangle BD, according to the law of cosines, BD square equals to AB square plus AD square minus 2 times AB times AD times cosine theta. So BD is the missing side, so it is, so it is BD square equals to AB square. AB is 4, therefore AB square is 4 squared, that is 16, plus AD square. AD is 4, therefore AD square is 4 squared, that is 16, plus 2 times AB, that is 4, times AD, that is also 4, times cosine theta. So in total, according to question 1, we have found out that BD square equals to 16 plus 16, plus 2 times 4 times 4 times cosine theta. So BD square equals to 16 plus 16 is 32, plus 2 times 4 times 4 is minus 32, so total this expression equals to minus 32 times cosine theta. So according to equation 1, we have found out that BD square equals to 32 minus 42 times cosine theta. The next step, implemented the law of cosines in this right triangle, triangle DBC. According to the law of cosines in this right triangle DBC, DB square equals to BC square plus DC square minus 2 times BC times DC times cosine 180 degrees minus theta. But again, this right triangle DBC, according to the law of cosines, the following equation is 2. DB square equals to BC square plus DC square minus 2 times BC times DC times cosine 180 degrees minus theta. We have the trigonometric identity that states that cosine 180 degrees minus theta equals to minus cosine theta. Therefore, we can substitute cosine 180 degrees minus theta in this equation by minus cosine theta. We did it, and we found out that in total dB square equals to BC square. BC is 6, therefore BC square is 6 squared, it is 36, plus DC square. DC is 8, therefore DC square is 8 squared, it is 64. So we have dB square equals to 36 plus 64 minus 2 times BC, that is 6, times DC, that is 8, times cosine theta. We substitute cosine 180 degrees minus theta by minus cosine theta. So we have here minus times minus is plus. So this expression is a positive expression. So now we found out that dB square equals to 36 plus 64 is 100. Here we have minus 2 times 6 is 12 times 8 is 96. So total this expression equals to 96 cosine theta. So according to equation 2, I have found out that dB square equals to 100 plus 96 times cosine theta. This is according to equation 2, and according to equation 1, we only found out that dB square equals to 32 minus 32 times cosine theta. So according to equation 1, we found out that dB square equals to 32 minus 32 times cosine theta. Well, according to equation 2, we found out that dB square equals to 100 plus 96 times cosine theta. So we have two different equations for dB square. Therefore, we get the equation 3 that says that dB square according to equation 1 must be equal to dB square according to equation 2. dB square according to equation 1 equals to 32 minus 42 times cosine theta, and it must be equal to dB square according to equation 2, this is equals to 100 plus 96 times cosine theta. Here subtracted 32 from this equation, so here 32 gets cancelled, and we left only with minus 30 in this side of the equation, only with minus 32 times cosine theta, while on the other side of the equation we have 100 minus 32 is 68 plus 96 times cosine theta. So in total we actually found out that minus 42 times cosine theta equals to 68 plus 96 times cosine theta. Here we subtracted 96 cosine theta from the equation, so here 96 cosine theta we get cancelled. On the other side of the equation we have minus 42 cosine theta minus 96 cosine theta is minus 128 cosine theta. So total we found out that minus 188 cosine theta equals to 68. So here we divided this equation 3 by minus 198. And found out that cosine theta equals to 68 minus 128. So cosine theta equals to 68 minus 68 over 128. Here we divided both the numerator and the denominator of this expression by 2. Minus 68 over 2 is minus 34, and 182 over 2 is 64. Likewise, we divided this equation also by 2. Minus 44 over 2 is minus 17, and 64 over 2 is 32. So in total we found out that cosine theta equals to minus 17 over 32. So use the trigonometric identity that says that sinus square theta plus cosine square theta equals to 1. Here subtracted cosine square theta from this equation, and found out that sinus square theta equals to 1 minus cosine square theta. So here we took out all of this equation and found out that sinus theta equals to the square root of 1 minus cosine square theta. We already found out that cosine theta equals to minus 17 over 30. Therefore cosine square theta must be equal to minus 17 over 32 squared. Minus 17 over 32 squared equals to 0.2822. Therefore we can substitute cosine square theta here by 0.2822. We did it and we found out that sinus theta equals to 1 and minus cosine square theta is 0.2822. 1 minus 0.2822 is equal to 0.7177. So inside the root we have to with 0.7177. So sinus theta equals to the square root of 0.717. The square root of 0.717, the square root of 0.7177 is 0.847. So in total we actually found out that sinus theta equals to 0.847. What is the value of dB? This is the value of this sine dB or cone dB. According to equation 1, we only found out that dB squared equals to 32 minus 32 times cosine theta. So dB squared equals to 32 minus 32 times cosine theta. Cosine theta is minus 17 over 32. Substitute cosine theta here by minus 17 over 32. So here we have minus times minus is plus. So this expression is a positive expression. And we have 32 in the denominator, 42 in the denominator, so 32 will get cancelled, and the left only plus 17. So in total we actually found out that dB squared equals to 32 plus 17. 32 plus 17 is 49. So dB squared equals to 49. Here we took out of this equation and found out that again, we found out that in total the dB squared equals to 49. Here we took out of this equation and found out that dB equals to the square root of 49, that is 7. So in total we actually found out that dB equals to 7 units in itself, and sinus theta equals to 0.847. So in the next step we included the law of sines in this triangle ABD. So please click on the law of sines. the law of sines is true in any triangle. This is triangle ABC that could be any triangle. Triangle ABC is inscribed by this circle. AB equals to C units in half, AC equals to B units in half, BC equals to A units in half. This is angle BAC. This is equal to capital A degrees inside. This is angle ACB. This is equal to capital C degrees inside. This is angle ABC. This is equal to capital B degrees inside. So in this drawing, according to the law of cosines, the following equation is true. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks triangle ABC. Okay, then again, according to the law of cosines, the following equation is true. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. So we can implement the law of sines in this triangle ABC, why? Because of the fact that triangle ABC is inscribed by this circle. Why triangle ABC is inscribed by this circle? Because of the fact that all the three vertices B, A, and D lie in the circle. So we can implement here the law of sines in its full version. That is to say, according to the law of sines in its full version, this triangle ABC, this triangle ABD, the following equation is true. BD over sinus theta equals to 2R. Again, BD over sinus theta equals to 2R, and R is the radius of this circle that blocks the triangle ABD. So according to the law of sines, in the triangle ABD, the following equation is true. DB over sinus theta equals to 2R. We found out that DB equals to 7 and sinus theta equals to 0.847. So 7 over 0.847 is equal to 8.2644. So today we should find out that 8.2644 equals to 2R. Here we divided the equation by 2 and finally found out that R, that is the radius of this circle, that is the radius that we are looking for in this question, is equal to 8.2644 over 2, that is 4.132 units in circle. So today we should find out that the radius of this circle is equal to 4.132 units in circle. Okay, so finish to repeat the first question. The next step, repeat the solution of the second question on both methods. In the second question, our task is to find out the area of this green shape. So the drawing, we have the big rectangle ABC. AP equals to 5 units in half, BB equals to 4 units in half. This is again ACB, this equals to 2 theta. Again, our task is to find out the area of this green shape. So we start with the first method. So first of all, we found out the missing angles in this drawing. This is the big right triangle ABC. This big right triangle ABC, this is a right angle. This angle equals to 2 theta, therefore this missing angle must be equal to 90 degrees minus 2 theta. According to the rule that says that the sum of the angles in the triangle is equal to 180 degrees. That is to say, 90 degrees minus 2 theta plus 2 theta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees, that is the sum of the angles in a triangle. Likewise, in this right triangle PBC, this angle equals to theta. This angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus theta, according to the sum rule that says that the sum of the angles in any triangle is equal to 180 degrees. In the next step, we did the construction. That is to say, from point B, we draw perpendicular on AC. Again, from point B, we draw perpendicular on AC. So this angle equals to 90 degrees inside. This angle also equals to 90 degrees inside, according to our construction. We define the touching point of the perpendicular from point B in AC. This point is point Q. When we did this construction, we get the green arterial CQP. This green arterial CQP. This angle equals to 90 degrees. This angle equals to theta, and therefore this missing angle must be equal to 90 degrees minus theta, according to the sum rule that says that the sum of the angles in any triangle is equal to 180 degrees. Notice the size of this missing angle in PQ. According to the rule that the sum of the angles in any triangle is equal to 180 degrees, we get that 2 theta plus 90 degrees plus the missing angle that we define as y. Actually, 90 degrees minus 2 theta plus 90 degrees plus this missing angle that we define as y. Total must be equal to 180 degrees. Repeat again. 90 degrees minus 2 theta plus 90 degrees plus this missing angle that we define as y. In total must be equal to 180 degrees. So here we subtract 180 degrees from this equation. So here 180 degrees minus 180 degrees is 0. Here we have also 90 degrees plus 90 degrees is 180 degrees, so those two expressions also will get cancelled. After we subtract 180 degrees from this equation, here we left with 0, while on the other side we have here y minus 2 theta. This is minus 2 theta plus y equals to 0. Or y minus 2 theta equals to 0. Here we add 2 theta to this equation and find out that y equals to 2 theta. So the missing angle APQ is equals to y is equals to 2 theta degrees in size. So in the next step, we prove that those two triangles can go into each other according to angle side angle rule. So why those two right triangles can go into each other? First of all, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. In addition, PC is the common side that belongs to both angles, so we can write down that PC equals to itself is the common side that belongs to both angles. And finally, those two angles are both equal to theta, therefore they are equal to each other. So in total, we found out that those two right angles can go into each other according to angle side angle rule. That is to say, we found out that those two angles and the side that is included between those two angles is actually side PC in this rectangle are corresponding equal to those two angles, and the side that is included between those two angles that is side PC on this right angle. And therefore those two right angles can go into each other according to angle side angle rule. From the fact that those two right angles can go into each other, we derive that their corresponding sides are equal to each other. That is to say, PQ equals to PQ equals to PB. Or PB equals to PQ. PB is 4, so can I tell that PB is 4? So from this equation, 4 equals to PB equals to PQ. We have that PQ equals to 4. PQ equals to 4. It is very easy to say that the big rectangle ABC is similar to this small rectangle AQP. So why those two rectangles are similar to each other? First of all, this angle A, is a common angle that belongs to both angles. So we can write down that angle A equals to itself is a common angle that belongs to both angles. In addition, those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, those two angles are both equal to 2 theta and therefore they are equal to each other. So we found out that all the fingers of this big right triangle ABC correspond equal to all the fingers of this green small triangle APQ. Therefore, those two right triangles are similar to each other according to angle similarity rule. And again, in total, we found out that the big right triangle ABC is similar. This is the sign of similar to the small green triangle APQ according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AP of the green small triangle or side AC of the big triangle ABC is equal to side PQ of this small triangle or side BC of this big triangle ABC. So again, from the fact that the small right triangle APQ is similar to the big right triangle ABC, we know that the following relationship exists between the sides. We know that side AP of the small triangle or side AC of the big triangle equals to side PQ of the small triangle or side BC of the big triangle. AP equals to 5, AC equals to A according to our definition, and BC equals to B also according to our definition. So AC is A and it equals to PQ. PQ is 4 over BC. BC equals to B according to our definition. So in total, if you found out that 5 over A equals to 4 over B, if we cross multiply this equation, if I found out that 5b equals to 4a. That is to say, if we define a as 5x, that is to say, if we substitute a by 5x in this equation, we get that 5b equals to 4a. A is 5x. So we can substitute a by 5x. So in total we get that 5b equals to 4 times 5x. If we divide this equation by 5, so in this side of the equation we left with b equals to 4x. So b equals to 4x. In total, if you found out that if a equals to 5x, then b must be equal to 4x. So we can argue that if AC equals to A equals to 5x, then BC equals to B equals to 4x. So in the next step, implement the Pythagoras theorem on this big rectangle ABC. According to the Pythagoras theorem on this big rectangle ABC, AC squared equals to AB squared plus BC squared. And again, the big rectangle ABC, according to the Pythagoras theorem, AC squared equals to AB squared plus BD squared. AC equals to 5x. Therefore, AC squared equals to 5x squared, that is 25x squared, and this equals to AB squared. AB is 5 plus 4, that is 9, therefore AB squared is 9 squared, that is 81, plus BC squared. BC equals to 4x, therefore BC squared equals to 4x squared, that is 16x squared. So in total, we found out that 25x squared equals to 81 plus 16x squared. If we subtract the 16x squared from this equation, if I found out that 25x squared minus 16x squared is 9x squared equals to 81. If we divide this equation by 9, if I found out that x squared equals to 81 over 9 is 9. X squared equals to 9. If we took out of this equation, if I found out that x equals to the square root of 9, that is 3. So x equals to 3 is instead. BC equals to 4x, therefore BC equals to 4 times 3, that is 12. Likewise, AC equals to 5x, therefore AC equals to 5 times 3, that is 15. Our test was to find out the area of this green shape. So what is the area of the green shape? The green shape is actually the green triangle ABC. So we have to find out the area of the green triangle APC. I should know that the area of any triangle equals to the base of the triangle times the height of the base times the height of the base over 2. Choose the base of this green triangle ABC is AP. Therefore, the height to the base must be 90 degrees with the extended base AP. The extended base AP is AB. BC is definitely 90 degrees with AB because this is a right angle. So the height to the base is BC. The base is AP. The height to the base is BC over 2. AP is 5. BC is 12. Again, AP is 5, BC is 12 over 2. So in total, the area of the green shape equals to 5 times 12 over 2. 5 times 12 is 16, 60 over 2 is 30. So in total, if you found out that the area of this green shape, that is the area that we are looking for this question, is equal to 30 square units in size. This is according to the first method. In the next step, we solve this equation according to the second method. In this white lower triangle PBC, tangent theta equals to PB over BC. Again, tangent theta equals to PB over BC. And again, in the no right BBC, according to the basic trigonometric identities, tan theta equals to PB over BC. PB is 4, BC is B according to our definition. So we substitute PB by 4 and BC by B. So in total, if you found out that according to equation 1, tan theta equals to 4 over B. In this big right triangle ABC, tan 2 theta equals to AB over BC. Again, tan 2 theta equals to AB over BC. The big right triangle ABC, tan 2 theta equals to AB over BC. AB is equal to 5 plus 4, that is 9, over BC. BC is B. Again, AB is 9 and BC is B. So in total, tan 2 theta equals to 9 over B. According to equation 2, tan 2 theta equals to 9 over B, and according to equation 1, we only found out that tan theta equals to 4 over B. We have the trigonometric identity that says that tan 2 theta equals to 2 tan theta over 1 minus tan square theta. So we can substitute tan 2 theta here by 9 over B, and tan theta here by 4 over B. We did it, and we found out that according to equation 3, tan 2 theta equals to 9 over B, and it equals to 2 times tan theta. Tan theta is 4 over B, over 1 minus tan square theta. Tan theta equals to 4 over B, therefore tan square theta must be equal to 4 over B squared. 4 over B squared equals to 4 squared, it is 16 over B squared. So it is 16 over B squared. So in total, if you know that according to equation 3, 9 over B equals to 2 times 4, that is 8 over B, over 1 minus 16 over B squared. Here of course we multiply this equation by 1 minus 16 over B squared. So I found out that nine over B times 1 minus 16 over B squared equals to 8 over B. Here we have B on both sides of this equation, so B will get cancelled. So on this side of the equation we have to leave 8. If 8, while on the other side of the equation, B will get cancelled, we have to leave 9 times 1 minus 16 over B squared. Here we open the brackets, so we have 9 times 1 is 9, and 9 times 1 is 16 over B squared equals to 9 times 1 is 16 is 144 over B squared equals to 8. Here we subtracted 8 from this equation, and I found out that 9 minus 8 is 1, so 1 minus 144 over B squared equals to 0. 8 over 8, 8 minus 8 is 0. So we added 144 to this equation, equation 2, and I found out that 1 equals to 144 over B squared. So we multiplied this equation by B squared, and I found out that B squared equals to 144. Here to go to all this equation, I found out that B equals to the square root of 144, that is 12. So in total, we found out that BC equals to B equals to 12 units in its length. Our test is to find out the area of this green shape. What is the green shape? The green shape is actually the green triangle ABC. So our test is to find out the area of the green triangle ABC. Actually, we know that the area of any triangle equals to the base of the triangle times the height of the base over 2. So we choose the base of this green triangle ABC as AP, and the height of the base must get 90 degrees with the extended AP. The extended AP is AB. Indeed, CB gets 90 degrees with AB because this is the right angle. So the height of the base is CB over 2. And again, the base is AP according to our choice, and the height is BC. But BC equals to B, and B equals to 12. So BC is 12. BC is 12 over 2. AP is 5, so AP by 5. So the area of the green shape in total equals to 5 times 12 over 2. 5 times 12 is 60, and 60 over 2 is 30. So in total, we found out that the area of this green shape on both methods is equal to 30 square units in size. Okay, thank you very much.